All right, welcome to another episode of Python. And this time we're going to be doing some object-oriented programming. All right, this we're going to be looking at in the next few minutes. A crash course on object-oriented programming, right? So, object-oriented programming allows you to treat entities in your software, in your code as objects. Well, funny enough, Python itself is object-oriented. Everything is an object. Every single thing. So if you're used to functional programming, you create a function that takes in an input and returns an output, right? In this, instead of creating functions, you're going to be creating objects. Now, objects are able to execute functions. Technically, let's even look at it from a real life scenario, right? I'm human. So why am I human? Because I can do a couple of things. I can move, I can respirate, I can eat, I can die, and so on and so forth. MRNIGERD. Remember that from school or something, right? Yeah. Okay. So I am an object in this sense because I can do these things. Also, remember, I am human. I have specific attributes. I have color. My color is probably green or blue or white, or so there are some valid colors, right? Those things about me are called attributes. Those things I can do are called methods, right? I'm already breaking. So if we look at an animal, for example, let's pick up an animal. Let's say a dog, right? So a dog will be defined by this. That's it. What I've just done, we've just created a dog class, right? We have not yet created the dog itself, but we have defined how the dog is going to look like. Of course, in this case, we didn't define anything, we just said pass. But I'm saying that with that syntax, we can define what the dog looks like, what the dog can do, and so on and so forth, right? Before we continue, rather, when you are creating a dog, you need to create it with specific things. A dog cannot just exist without having some things about it that makes it a dog, right? It's quite interesting. Like if you look at the creation story, according to Christianity, it's analogous to saying that it is the breath of life that God gave into man that made him a living soul. So man did not exist. Man will not exist without that attribute called living soul, right? Okay, so a dog, for example, by default will have some things. Let's just say a dog can be created. When it's created, it has a name. Let's make the assumption, and it has an age. So what we have just defined is called the initializer, right? So we're saying that the initializer here, now there's a way you define it. This, you should be used to this in functional programming. Define the initializer is defined by _init. That's dunder init. Now, we said it's going to have a name and an age, right? Let's just make the assumption. Or let's just say it just has a name only. Okay, an age, yeah, because for it to exist, it must have existed for a while, right? Okay, so you see something new that I've just introduced? The self. So for an object to actually exist, it must be able to exist by itself. All of the attributes of the object are attributes of that object in itself. Look at it, I've mentioned self a couple of times, right? So self is the object itself. That's strange, yeah? An interesting recursion. Self is the object itself, right? So in this case, we are trying to reference the object so that when we are creating, remember this is a class, this is not the object itself, right? This is not the instance of the class. Let's use that word. So we're defining how the class is going, how the object is going to look like. So that when it is created, right, this name and age are going to be mapped technically to that object. Okay, let's go ahead. So we say self dot name. So we just explain now. So we are saying here that the name of the dog, right, is equal to name. Self dot age is equal to age. So this name is the exact same thing as this name, not this one. So the name of the dog will be called, so let's say I call this dog name. This will be dog name, right? I call this dog age, just so that I'm not confused. It's going to be dog age. Okay, so let's create a small dog object, right? Let's call it Kelly dog. So you're going to create a dog object. Of course, in our case, if I do this, see that there's a problem. It says that we need to include two arguments, dog name and dog age. Remember, I said a dog cannot exist if it does not have some specific things about it. In our case, we say that a dog must have a name and an age, right? So we need to correct that. Kelly is equal to dog. What's the name of the dog? It says Kelly. What's the age of the dog? 1 year old. Let's read that. So we're done. Once you print Kelly, tells you, oh, Kelly is a dog. Of course, this is information about where it is stored in memory, right? This is information about the current instance you are in. And ignore that for now. This is dog, right? Okay. So I can now get the Kelly dot name. That's Kelly dot age. That's 1, right? So I'm going to tweak this. I'm going to tweak this to the standard because, just a moment, let me show you. If I print help Kelly, I might be, oh, dog, I apologize. It says here that you need to enter dog name. Say dog has dog name and dog age, right? So that we do not confuse dog name and name. I'm going to go and change this to just name and age. Oh, sorry. All right, so if we reinitialize, Kelly is equal to dog, Kelly, we can even start saying name is equal to Kelly, if you want to be specific, age is equal to 1. Kelly.name, right? That works, yeah? Good. So let's even now say that we want to create more than one dog. So we just as we can create this instance. So this is called an instance attribute. We can also create class attributes. Class attributes are attributes of the class itself. Now, what that means is that I'm going to explain. Let's say if one do, how do we describe that a dog is an animal? The animal, for example, is common to the dog object, not necessarily whether a dog itself exists. So even before Kelly is created, the dog is an animal. Does that make sense? Even before the Kelly object itself, that's the dog called Kelly, is created, dogs are always animals. So we can represent that. You see what we are doing? We are trying to represent real life objects in our code. Same thing, but what we are doing here, we just say species is equal to animal. That's it. And of course, all we can do here is that let us go and reinitialize dog, Kelly rather. Did I miss something? Oh, I'm sorry. I must have copied the wrong stuff. Age. So if I say Kelly, the species, that's what that's an animal. If you notice, we didn't have to create the species by default. So it's more like to set the default, some default values for that particular class. Right? Good. So what's next? We've defined what the dog, who the dog is. How about let's define what the dog can do, right? Let's try that. So what does a dog do? A dog barks, sorry. So let's make modifications to this and allow the dog to bark. So we create a new So what does a dog do? A dog barks, sorry. Let's call it a sound. And we say print return. Okay, let's do print. Let's do print self.name. Remember, that's from here. Okay. Is barking sound, right? So what this does, you can either decide to print, you can decide to return, right? Okay, so remember these guys did not, okay, let's use the return, just so that we make it, yeah, different. So you hit enter, let's initialize Kelly, same thing. All we can do is we do dir Kelly, it tells us that you can skip all of this, has a name, has an age, can speak, and has a species. So if I do Kelly.species, which we know already should be animal, we can do via help, or let's say Kelly.speak. If I hit Shift Tab, it tells me, oh, okay, I should enter the sound. So let's just create a sound and call woof. What happens there? It says Kelly is barking woof. Okay. So it's getting interesting, right? Yeah. All right, so let's change the age of the dog. So after a year, for example. So what we'll do is let's create a method called grow. So the dog can let's allow the dog to grow by say an extra year. Right? So Grow, for example, will be a method because it's an action that is taken by the dog. The change or the grow method affects an attribute of the dog called age, right? So let's try that out. Same drill, pick this up. And we create grow, right? Now what we're saying is that that's really, so we can say return self dot name is now self dot age years old. Now, if I hit shift enter, let's go pick this up again. Kelly has been defined. What's Kelly's age? Let's see. Kelly's age is 1. So we ask Kelly to grow. Says Kelly is now 2 years old. Let's find that out. Now Kelly's age is 2. So you see, somehow we've created a method that is also able to modify the attributes of that same method, right? All right, in the next episode, we're looking at class inheritance. So if we have a dog, instead of creating it as a species called animal, right? What if we decide to create a superclass called animal that can do some things? Then a dog can bark, right? A horse can neigh, a chicken can, a cock can crow. A cock can crow, right? And various things that you can do as an animal, right? So you can decide to create animals under the animal class, different classes of animals under the animal class. If you did biology, we are probably beginning to speak like biologists. Yeah, very correct. And yeah, it works. Okay, so that will be in the next lesson. See you in the next lesson.